Oops, I was trying to get that out there. Reflections. There, he looked for his reflection back there. He can't find it.
Oh no.
Those the cats are the smart ones that look behind the mirror.
Thanks. What would you feel like if you didn't jump
So now that we've seen the reflections in the funny home videos, back to our notes. First example. You get the notes back to the right size. There we go. All right. It says, identifying reflections. In a reflection, a figure and its image are congruent. So, which they are. Letter A, B, and C. First of all, let's go through these and tell me whether the transformation is a reflection. Yes or no? Is letter A, is this a reflection?
Yes. Yes.
Okay, we all agree yes. How about B?
No.
No, it looks like they just kind of slid it. And the fact, or the true test is if you were to fold it on that line of reflection, if you were to fold it like this and fold it over on this line, does it exactly match up? This one does. If we folded this over, would it match?
No.
No. How about C?
Yes.
Yes. Now, what is the line of reflection? Obviously, this one doesn't have one because it's not a line, it's not a reflection. But how about A? What is A? What is the line of reflection? Where would you fold it?
The x-axis.
Yes, right here is where you would fold it, and this is our x-axis, this was our y. So the line of reflection is the x-axis. How about for C then? What is the line of reflection for C? Right here. It's kind of like the butter between two pieces of bread. Where do you fold it? That one would be the y-axis. All right. Now, just like on yesterday's assignment, there's two ways to come up with the answer. You need to know both in case they're not on a graph for you. Now, looking at this first one, it says you can use coordinate notation to describe the images of figures after reflection in the axes of a coordinate plane. Here's what that means. Here is an example of a reflection in the x-axis. The main thing you need to know, when they want you to reflect something, they'll say, here, graph the original, now reflect it in the x-axis. That means it has to fold over then on the x-axis right here. That is its line of reflection. Now, like in that one little clip we watched earlier, the mad scientist math guy, we could start, which one of these, by the way, is my original, the top or the bottom? The top, because it is what?
It has no apostrophe.
Doesn't have the apostrophes. These have the dashes, the apostrophes. We know then that this one is our transformation, our reflection. Now in that video, they would just count from the line or the mirror, as they would say it in. They had to have been in where? England?
London.
London.
Okay, so they would count. They would be one from the line of reflection, so you'd have to go one down. Excuse me. Whoa, excuse me. I have to edit that out. Okay, back to the other one. The A. How many units am I from the line of reflection? 3. So I need to go another 3 below it, and you end up here. So it's easy to graph a reflection without even having the ordered pairs. However, on a test or a quiz, I'll need the ordered pairs, like on your worksheet. Well, obviously here they give it to you. But say they weren't listed here. Right here is the clue. If we want to reflect it in the x-axis, you multiply the y by a -1. So notice this one here, this is a -2. I'm just going to write it bigger. -2 and 3. This is always x, this is always y. I want to reflect it in the x-axis, so therefore I take this y and I multiply it by a -1, and that just changes its sign. A 3 times a -1 turns into a -3, and that's what it is down here. You have -2, your x stays the same, and now we have -3 instead of a +3. So therefore down here, I'm reflecting it in the x-axis, so my x stays the same. But my y, it was a +1, take it times a negative or switch its sign, you get a, so my new one is for -1. So you can come up with the ordered pairs without having a coordinate plane to graph them on. So then you just do the opposite over here if they want to reflect it in the y-axis. So there's my y-axis, here's my original. I could go, okay, fine, I'll go 2 units over, 2 this way. Go 4 this way, 4 this way. Is that 3? Anyway, I think I said that right. Now what do we need to change? Up here's our original. We have a -4 and 3. And down here's my original, -2, -3. What do I need to change? My x and my y. My x and my y. I'm reflecting it in the y-axis. So I should ask you first, I'm reflecting it in the y-axis, which one stays the same? If I'm reflecting it in the y-axis, the y stays the same. So therefore my 3 stays the same. Multiply my -4 times the -1 and I get a +4. Look at that. +4 and a 3. Over here I'm reflecting it in the y-axis, so the y stays the same. Leave that a -3. But I need to change the x to not a -2. Take it times the -1 and I get a +2. And look at that. +2, -3 is my reflection. Let's practice. All right, first off, I want you to draw the triangle with these ordered pairs. Connect your vertices to make your triangle. And label it, please. A, B, and C. And hopefully it'll match mine. There's the original. Any questions on how to get to the original? We all good? We're there? So now we need to plot. What do they want us to reflect it in? The x or the y-axis?
X.
They want us to reflect it in the x-axis. Oops. In the x-axis. So which one of these are going to stay the same? If I'm going to reflect it in the x-axis, which one stays the same?
The X.
If we're going to reflect it in the x-axis, all of the x's stay the same. So 2, 2, and 4. All the y's we need to take times a -1. So what are my new ordered pairs there for the y's then? What do I get here for the A?
-2.
-2.
-5.
Excellent. -5. And the last one?
-1.
Perfect. Now if you didn't have a graph, there's your ordered pairs to put on a quiz. And maybe some of you like to do that to start out with anyway, and then plot it. Now put the reflection. How many are going to use the new ordered pairs we just came up with to plot them? Only a couple. How many are just going to count how many units from each one? Okay, that's fine too. Go ahead. So plot the reflection that we now have in the x on our x-axis. Did it work? It's all matched? All right, on to the next one. Okay, first thing we want to do is what? Plot what? Excellent, thank you. Plot the original. I'm going to do this one. Here's my original. Does yours match mine?
Yeah.
Excellent. Now, obviously it's easy just to go over here and plot and plot. Let's do the ordered pair first. Let's practice the harder way first. What will my new ordered pairs be for the reflection? It's a reflection in the what axis? On the y-axis, so which one stays the same?
1.
Which? The y is at the first or the second one?
Second.
Okay, so those all stay the same. A is -3, this one stays a 4, this one stays a -3. So what did my x's turn to on the A?
1. 4.
4. How about the B?
4.
Good. And the C, take that times the -1 and I get There's my new ordered pairs. Let's see if they match. If we were to just go across. 1, 1. What do I label this one? What is this one?
C.
This is my new C. My new A is 1, 2, 3, 4. 1, 2, 3, 4. There's my new A. My B is 1, 2, 3, 4. 1, 2, 3, 4. Connect the vertices. There's my reflection. Do my ordered pairs match what we came up with? 4, -3. 4, -3. Beautiful. 4 and 4. 4 and 4. Nice. And the last one, 1 and -3. 1, -3. Uh-oh. Steve is listening. 1, -3. Good. So that worked. Now, lines of symmetry, lines of reflection, so to say. The first one on your homework on your notes is a lightning bolt. Go Chargers. Is there any way you can draw a line down the middle, diagonally, anywhere down that lightning bolt, so that if you were to fold it over, it would match exactly?
No.
I agree. No. There is no line of symmetry there. How about B in your notes? That part?
Yes.
Okay, I agree with yes. How many?
1.
1.
1? Do you have it drawn on there?
Yes.
Did you do it or? Oh yeah, you get to do that on your notes. That's not on there for you. Do you all agree on 1?
Yeah.
Yeah.
Very good. And that's where it's at. Draw it on if you haven't already. And the third one is?
Yes.
Yes.
Oh, you all agree yes?
Yeah.
Any naysayers? All right, so you all agree on the yes. So all right, yes. Oops. Ooh, did you see it? Oh, no peeking.
I didn't see it.
All right, I agree on the yes. Now we need to agree on how many.
2.
There's
One,
more than
two,
2.
one.
There's like 4.
Who says? Okay, who says 1? Who says 1? Who says 2? Ooh, look at all those smart people out there. You have 2 lines of symmetry, and there they are. Draw them in if you were missing one.
What about going straight up and down and going side to side?
Well, let's take a peek. Straight up and down.
Yeah.
If I folded that over, would they match
Oh, I
identically?
guess, yeah.
Good question, though. And that would be like if I went this way. If you were to fold it over, would it match identically? No. All right. Yes or no for number 2. What kind of a figure is that, by the way?
Parallelogram.
A parallelogram. I just like to say parallelogram. All right. We have to agree. Yes or no?
Yes.
Oh, we are in
No.
disagreement.
No. No.
Yes.
No. No.
Who says yes? Who says no? Who says yes? You're wrong. Sorry.
What?
And no, you cannot do a parallelogram. And here I have one cut out. Sorry for the virtual world. You can't see my cut out one. So I could kind of show you in the virtual world on the thing here. If I were to cut this in half and fold it over, is this going to fold over and match up down here? Okay, for those of you out here in my classroom,
That's not the color.
does that match up?
No.
No.
There's
How about diagonal?
Yeah.
Oh, let's see, virtual world. You're just gonna have to go along with the class when I show the demonstration. Write down the peaks. Write down the corners. Does that match up?
No.
No, because this is a parallelogram. This is not a or a
Rhombus.
rhombus. Okay. So therefore we know that that one is a
No.
big old no. Doesn't work any way you try to fold it. It is not going to work. How about number 3?
Yes.
Yes.
That was pretty easy, isn't it? A rectangle. So we all agree on the yes. Now we have to agree on how many.
2.
2?
4.
4?
2.
Who says 2? Who says 4? 2's win. Why? That's kind of like the parallelogram. It is a rectangle. If I folded it over diagonally. Oh, did you guys see that now?
No.
Maybe. If I went this way diagonally,
They want it square.
are they going to fold up exactly? No. If it was a square, would it?
Yes.
Then it would. But with a rectangle, those diagonals do not work. So it only has 2. How about the last one? Yes or no?
Yes.
Yes.
Okay, that's an easy one to agree on. Yes.
Oh, yeah.
How many?
1.
5.
1.
1.
5 and 1. Who says 1? Ooh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Who says 5? 1, 2, 3, 4, 5, 6, 7. So that means all of you didn't vote, but let's see who's right out of the voters.
It's 5.
Drum roll.
1.
How many is that?
5.
Here they are. Here they are. 1, 2, 3, 4, and 5. There are 5 of them. Please draw them on yours if you haven't already. Okay, your homework. Worksheet 13.5. Due tomorrow. Also due tomorrow, blocks 3 and 4 is page 1 in your review packet, the Friday review packet.